Docstores in Retrieval Augmentation. Overview. Description. Docstores are specialized storage systems used to efficiently store, manage, and retrieve documents in Retrieval Augmented Generation RAG frameworks. In RAG, the model retrieves relevant documents from a docstore to augment the input before generating a response, improving the accuracy and relevance of the generated content. Key components. Document storage. Description. The underlying database or storage system that holds the documents. It should support efficient storage, indexing, and retrieval of large volumes of text data. Indexing. Description. Mechanisms to create and maintain indexes that allow for quick and efficient searching of documents based on various criteria, such as keywords, metadata, or embeddings. Retrieval mechanism. Description. The process of querying the docstore to find and retrieve the most relevant documents based on pay. Input query. This can involve traditional keyword-based search or more advanced techniques like vector search. Using embeddings. Document ranking. Description. Techniques to rank retrieved documents based on relevance to the input query. Ensuring the most pertinent information is presented to the model for augmentation. Steps. Step 1. Description. Document ingestion. Collect and ingest documents into the docstore. This involves pre-processing the documents, extracting relevant metadata, and storing them in the database. Step 2. Description. Indexing. Create indexes for the ingested documents to facilitate efficient searching. Indexes can be based on keywords, metadata, or embeddings generated using neural networks. Step 3. Description. Query processing. When an input query is received, process it to determine the most relevant search criteria. This can involve tokenizing the query, extracting keywords, or generating query embeddings. Step 4. Description. Document retrieval. Use the search criteria to query the docstore and retrieve a set of candidate documents. This can be done using traditional search techniques, e.g., inverted index or vector search for embeddings. Step 5. Description. Document ranking. Rank the retrieved documents based on their relevance to the input query. Techniques like TF-IDF, BM25, or neural ranking models can be used for this purpose. Step 6. Description. Response augmentation. Use the top-ranked documents to augment the input query. This can involve concatenating the query with relevant passages from the documents or using more sophisticated fusion techniques. Step 7. Description. Generation. Pass the augmented input to a language model, e.g., GPT-3, to generate a response. The retrieved documents provide additional context, improving the relevance and accuracy of the generated content. Step 8. Description. Post-processing. Process the generated response to ensure it is coherent and contextually appropriate. This can involve filtering out irrelevant information or refining the response based on additional criteria. Considerations. Scalability. Description. Ensure the docstore can scale to handle large volumes of documents and support efficient querying and retrieval in real time. Relevance. Description. Implement effective ranking mechanisms to ensure the most relevant documents are retrieved and used. For augmentation. Enhancing the quality of the generated content. Freshness. Description. Regularly update the docstore with new documents and reindex existing ones to maintain pay, relevance and accuracy of the stored information. Security. Description. Protect the docstore from unauthorized access and ensure compliance with data privacy regulations, especially when handling sensitive information. Technologies. Inverted index. Description. Use inverted indexes for efficient keyword-based search, allowing quick retrieval of documents containing specific terms. Vector search. Description. Implement vector search using embeddings to find semantically similar documents, enhancing the relevance of the retrieved content. Neural ranking models. Description. Use neural networks to rank retrieved documents based on their relevance to the input query, improving the quality of the augmentation process. Integration. API integration. Description. Integrate the docstore with the retrieval and generation components of the RAG framework through APIs, ensuring seamless data flow in processing. Continuous monitoring. Description. Monitor the performance of the docstore, including retrieval times and accuracy, and make adjustments as needed to optimize efficiency and relevance. Feedback loop. Description. Implement a feedback loop to continuously refine the document retrieval and ranking processes based on user interactions and feedback, enhancing the overall effectiveness of the RAG framework.